stationary points. Okay, so they are saying you are supposed to sketch the following graphs. Well, if you look at the function y equals to x cubed minus 1, if you were to sketch all cubic functions, they take a certain shape. The graph of y equals to x cubed. So this is, let's say, dx equals to x cubed. So when you have minus 1, it means it will pass at minus 1. So it's like this whole thing coming down.
Exactly.
You follow?
Yes.
If you take, for example, now this is not necessary, but I'm just putting it out there. So this is the difference of two cubes. But if you were to solve this, this is going to be equal to that, and x will be the cube root of 1, which is x equals to 1. So it's also going to then pass at 1. You follow? So the graph that we are then looking at, right, somehow, it's just a sketch, right? So this could be my graph of y equals to f of x, which is the graph that I have here. So we are looking at the stationary point, or inflection. And at that point of inflection, for example, your gradient
dx equals to 0.
gradient is equal to 0. So they'll ask you to find the coordinates of the stationary point. So how will we find the coordinates of the stationary point? What do we do?
Yeah.
In this case, we are not determining what they are. We're not asked whether the question is it the maximum or is it you understand? You're not asked to describe the turning points, the nature of the turning points. You are asked to find the coordinates of the turning point. So in order for you to find the coordinates of the turning point, what do you do with the function? You derive the function. So you say that function is there. So you're going to have, the function is y equals to x cubed. So dy dx will be 3x squared. The derivative of that is 0. Right. So what else do you do after you have now the derived function? You let that equal to what? 0. Let that equal to 0. Okay. So you say 3x squared is equal to 0. In fact, x here will also equal to 0. Okay. X is equal to 0. The point where x is equal to 0 is going to be somewhere here, right? Is it not so? So that's actually where it turns. Just the way that I drew mine. It's kind of, it looks like mine now, the turn's there, but it's really turning something like that. Just goes. Understand? Right. So now we have got the value of x. So we know now what our x value is. So it's 0. How do we find our y value? You substitute this into the original function. So when f of 0 is going to be 0 cubed minus 1, which is going to give you negative 1. So the turning point of that graph is actually right here at that particular place. You follow? That's where the turning point is. So that's how that particular question is done. It's basically straightforward stuff when you get to that. Right. So if you look at the next set of questions, you have got try not to read. So I'm going to write down the function. Okay. Where is that? I can take this off. So we have got the function that says find the coordinates of the stationary point of y equals to 2x cubed plus 3x squared minus 12x plus 7. The coordinates of the turning point. That's the first thing that you're supposed to do. Right? So how do you find according to the turning point? It's exactly the same condition than what we did before. You did what? You derive the function. So dy dx, because if it's given to you in terms of y, you go dy dx. If it was f of x, then you would have f dash of x, the prime notation. Okay? So what is the derivative of this function? 6x squared multiplied by 1 times plus, and then the derivative of the constant is just equal to 0. Right? So what are we supposed to do then? We are supposed to find the turning point. We're looking for dy dx equals to 0. So this becomes a quadratic equation.
Two numbers.
Where you solve for x, but then there's something that is interesting there.
Simplify it.
You can simplify it by dividing throughout by what?
6.
So this is going to be x squared plus x minus 2. This, by the way, it should factorize. You agree? So two numbers, negative 2, and then you get a 1. So I think it's 2, positive 2 minus 1. So x is equal to
What's the one?
negative 2, or x is equal to.
What's the one?
So we have got the x values of the turning point. So one will be negative 2, we have to find the other one. The other one will be 1, we have to find the other one. So what do we do with these values? We substitute them back into the original function. So f of negative 2 gives us 2. Did you work it out?
On it.
So what is it equal to? What is the output? Then you also do the same when that is equal to 1. What is the answer for that one? So punching with a calculator? Say what? Negative?
You don't need a calculator.
He's talking, but nothing is coming out. Huh? Negative 8 by 2 is negative 16. Yes? This is negative 16, right? And when you have this, it's going to be 12. It's negative 4. And that's going to be negative 4 minus, that's negative 11. Then you have got to, no, negative 4. And then you have to add 24. That's 20. Minus 7, 13. You get 13 also? 27. Oh. Okay, what's it of 27? So that point is 27 then.
Gracias.
And it's 1. This one is easy. Do you need the calculator for that?
0.
0. 2 plus 3. You see? That's 2. Plus 3 is 5. 5 minus 12 is negative 7. Minus 7 is negative 14. Is the answer not negative 14?
Negative 30.
You are saying 0.
So why are you saying minus? The formula is the.
Oh, that is a.
It's a plus
plus in front of it.
7.
Oh, this one is a plus 7.
Plus 7.
Oh, that's where
Yeah.
my whatever is wrong. Anyway, so this gives you then the 0. Okay, negative 7 plus 7. Okay, so those are then the coordinates of the turning points. Now, you are now supposed to determine, what does that question say? Could you say that out loud again?
Determine the nature of the people.
Yes, what do they want to know? Yeah, you read it. Determine the nature of the turning point. What is it that they want to know? Yeah? You are supposed to find out whether these turning points is a maximum or a minimum.
Second derivative.
So you have to do your second derivative.
derivative. Exactly.
So what is our function? Dy dx is equal to 6x squared plus 6x minus 12.
Exactly.
Then the square y dx squared will be 12x plus 6. You agree?
Yes.
You agree? Right. Now what do we do with that?
Substitute our x
The x values into that.
into the.
We don't let that equal to the x values.
No, we just substitute.
Oh, okay. So, if x is equal to -2, and you substitute it here, so you've got f of -2, that gives you 12, -2 plus 6.
Do the math.
What do you get as an answer here?
Come on, really?
-18? Are we?
Yeah.
-24? -18. So what can you tell me in this case? This here is less than 0.
So it's on max.
So the point, this point -2, this is a what?
27 is the maximum.
Is a maximum. Right? So when you sketch it, you know exactly where it is.
It's up there.
It's up there. If we do the same,
It's a local maximum.
yeah, local. You can actually call it the local maximum, the local minimum.
Yes.
When we substitute for 1, you get positive 18.
Yes, sir.
You understand that?
Yes.
So therefore, this point here is going to be a minimum. Okay, I'm just going to write minimum. You get the concept.
Yes, sir.
Now they are saying we should also sketch that graph. Well, I'm not going to focus too much on sketching. Okay? Because you have an idea. But let's suppose we sketch that graph. In order for you to sketch the graph, you should know what the y-intercept is and what is the x-intercept.
Yes.
What is the y-intercept going to be if you sketch that function? Let's
The
start
substitute.
here. If you sketch it, what is the y-intercept going to be?
Positive 7. Because substitute 0. Substitute 0.
Right. So it's also going to be something that goes like the previous one.
Right.
Okay. Let's see. Let's quickly sketch that. So I'm not going to work out the x-intercept. Just want to bring the point home where, because to find the x-intercept, we have to use some sort of factorization method.
Exactly.
Understand long division, trial and error. We're going to get to that part. Okay. In order to find the vector.
I see.
The value of x is. But you know that, let's suppose the y-intercept is going to be at 7. So if my 7 is up there, so this function is going to cut there. Alright. And also, you have got the points -2, 27. So -2, 27, let's say -2, 27 is point right out somewhere there, right?
Yeah.
So that could be the point like
Local maximum.
27. So let me even bring my 7 somehow down. Okay, so that's the point that is going to go. And the local minimum is going to be the point 1, 0. So it's going to come actually like at where 1 is. So it's going to be something that perhaps go like that, right? Now, as I said, again, this is just the way I drew it, right?
It's too steep.
Yeah, it's too steep, you know. You get the idea. Somehow, this is more or less how this graph
So
looks.
it was local. It doesn't really pass.
So this is going to be the 1.
Yeah. So it shouldn't it be like yeah.
Turn here.
Yeah.
There you go. At least you get it.
Yeah.
So I have to start over. So let's suppose it comes here.
Yeah.
Happy?
Of course.
Happy? So this is going to be the point.
-2, 27.
This is obviously the point.
1,
And this is obviously our function of x. More or less something like that.
Yeah.
Because of that, it means it's going to touch.
Touch.
So there was only 2 solutions there. The repeated one here. More or less that's how that function would look like. And also you have to go in this direction because that value of a is positive. Suppose this was a negative, then we would have started the other side. Now there he goes again. You know, this guy in his ways. You should have seen that. Good. Right. So don't need then to look at the second question because the questions are more or less a repetition of each other. The only difference that you have between those two questions is that looking at also a cubic function. Then you must determine the nature of these points, and then you sketch. So it's basically like the same thing.
A value is positive.
Yeah. Fine. That. Yes, I think you need to clean the board. You know the story. Why is it that I must explain to you your job description? We're getting there in terms of differentiation. Okay? It's just the vectors that are giving you a headache. Get closer and take pictures. Why do you move closer to the camera?
That's what we see.
So I can see.
Now he's blocking the camera. It's not easy sometimes being from Valvas. I think this guy is from, what do you call it, location there?
I'm staying from the
What is the location in Valvas? I blik is dorp man. I blik is dorp dan. Ek weet so kom ons reaksie, wat is ek blik is dorp? Kom ons dan ek dorp.
Sorry. Tem nível locação.
Yeah, I blik is dorp, I new location.
Tem nível local.
Yeah, see? You know it. Local. Aí como da. Okay, as he is cleaning, the next concept you are given more or less the same stuff, but you need to finish a few things.
Same.
It's the same concept, right?
Yes, we can even skip that one.
We can even skip that. You feel that we can skip that one?
Straightforward.
If you substitute a point A into your second derivative and you get 0 as an answer, this is maybe just something worth mentioning.
Yeah. Just mention.
Because we had what you call it, we spoke about stationary point. Here the question still says find the coordinates of the stationary points of each of the following curves and determine the nature of each stationary point. The nature of each stationary point. So we have got a function y equals to x to the 4 minus 2x cubed. So basic is basic. What do? You divide the x. You agree with me? This is a quartic function. When you differentiate it, you get a cubic function. So when we are determining the nature of the turning point, we're going to let that equal to 0. Yeah. So we're going to say
dy dx equals
is equal to 0. That is 4x cubed minus 6x squared is equal to 0. In fact, there's something common here. There's a 2x squared common. You agree? So here you've got 2x minus 3 equals to 0.
X equals to 0.
So you have got 2x squared equals to 0,
X equals
or 2x minus 3 equals to 0. So far so good. Well, if you manipulate this one's just going to give you x is equal to 0 because, divide that 0 by 2, the square root of 0 is 0. So that's one turning point.
x equals to,
Or x will equal to
what was it, the
3 upon 2 if you are manipulating that.
so
So we have the two values, but the question wants us to find the coordinates. Right.
second derivative.
When f of x is equal to 0, so we're going to substitute this into our function.
To find out
We don't even need to waste our time to know that the answer is equal to 0. So therefore, one of the turning points is going to be at the origin.
It is an inflection.
So one turning point is the point 0, 0,
Makes sense.
or the origin. If f of 3 upon 2, then you have 3 upon 2 to the 4th minus 3 upon 2 cubic. Okay? In order for us to find that, that's 9 upon 69. It's 81 over 16. You with me? 2 raised to the 4th. Minus 2 by 27 upon 8. We're really going to let you do this. without you basically calculating. It was 54 or 48.
Minus 27 upon 16.
Yeah, you are leaving me to work this out without a calculator. By 2. That's 100.
Okay.
What is this times 2?
Still
108.
it's minus
Not easy
minus
thinking in
20
African.
minus 27.
How much do you add here to get to that number?
27.
Is this the answer?
Straightforward.
Is that the answer?
Exactly.
So why do you have to do all this work? You know? So the second point is the point 3 halves, comma, minus 27 upon 16. So what is this as a decimal quickly? So this is like 1.5 and this is negative what?
Negative 1.6875.
It's about negative 1.7,
6875.
negative 1.7, more or less.
More or less.
Just to know when you sketch where it is, right?
Yeah.
Okay. So we have done that. That is the first part, like normal, like the previous question.
Second derivative.
But they want you to determine the nature of these points. So when you determine the nature of these points, you have to do the second derivative. So the second derivative, I don't know if your camera is catching here. So d square y dx squared.
Oh, let's just go straight.
What is our function?
12x squared.
Where is our derivative
It's
function?
there.
Here.
So this is 12x squared.
So that function becomes 12 x squared.
Minus
That's 3 times 4, take away 1. Then 2 times 6 is what?
12
Minus 12
x.
x. You understand? So we are going to substitute 0 into this function. Yes?
This is
In order
just 0.
to find that particular value.
Interesting.
So once you do that, you get nothing but 0.
It's not greater.
So if the square y dx squared is equal to 0, what can you tell me? That's the point of what?
Inflection.
With an xe, né? Just want to make sure I spell it correct. If you see that little note there at the example, when the second derivative is equal to 0, we use the first derivative test to determine the nature of the stationary point. What does that mean?
Substituting the first derivative.
We use the first derivative.
Instead of the second.
So that is the point of inflection. Right? Point of inflection.
We can't really determine if it's a maximum.
Exactly. Point
It's
of
like
inflection.
just
Okay. So therefore, what is the point that we have? This point here, 0, 0.
when x is 0 and when x is
0, 0. What if we try the other one? What is the other point?
1.1.
1.5.
Yes.
Yeah, leave it like that. So, you're not going to do that with me again. Please work it out and give me the answer. There's something there is nice. Oh, okay.
It's 9.
You get 9?
You got positive 9.
Someone gets negative 45. My goodness gracious. How did you get to negative 45? How did you get to 9? Who is right? Who's wrong?
Positive, come on, you can see, sir. It's just.
You also got
It's
9.
1.5.
Oyanja, calculator skills, AS level student. It is not easy. Let's check. Oyanja. So this is 9 over 4.
Come on, it's 1.
Oh, you see your mistake? Uh-huh. So I can accept the answer. You agree? Okay. So this is then d square y dx squared. You can see that this is greater than 0.
Which is a
So
minimum.
therefore, the point,
It's a minimum.
well, I'm running out of space here, but at this point here
It's a minimum.
is a what?
It's a minimum.
Is a minimum value. see if you sketch it. Now to get an idea, you have to sketch that. So when you look at the next function, not that we're going to do it anyway, but you'll have to multiply out the bracket first.
Then you get some quadratic.
Okay.
3x squared minus.
I'm giving you a chance to take your
It's a cube.
pictures before we look at question 2 on the next page, which is page 290. Is it okay? Take your picture with your phone because that's what you're doing.
That's why you brought your phone.
You brought your phone. You were there taking pictures now. This guy from Mondesa. And
When this is Rosago.
this is the same stuff. Just
Say that
given
again.
X notation. We are given Y notation. We use that.
Differentiation for you.
Okay, only when you are finding the first line of the derivative.
No, sir, what's
Then, in order for you to find the second derivative, is the question asks you to determine the nature.
What is it?
Which one?
The slide.
Okay, remember here, they did not yet explain the second derivative here. So here, the only way that you find the problem is to determine the point. Then you were supposed to determine by some sort of trial and error method. So here's where the sketching really comes in. Yeah. So then I just look at the second derivative. Remember that I was making is the point here, point there. So it's like graphing. Tani is calling. Go answer. Tani is calling. Which Tani is it?
What are you doing?
I'm here, I'm asking no. Okay, anyway. What is he doing? What is he doing? Come on, okay, he's still recording. You were just gonna let him do whatever he was doing there.
Look cool.
Is it cool? Let me
It's
see.
like
Let me see.
recording.
Do it. No Africans cannot be trusted sometimes. It's not easy. What is that saying? What's that is? Oh, it's Tani or your grandmother? Your mother's sister. Your mother's sister. Hold up. Oh, why you call it Tani or something? Granny number 2. Granny square. Is it confusing? Granny square. Everything is fine. They love you. They wish you the best. Yes. Okay, good. Now we go to question 2 on the board. Anyway, right? They are saying dy dx is equal to x squared. No, that's a negative there.
Yes.
Plus 5x minus.
Some
For this, we are supposed to the first find the x coordinate of each of the stationary points of the curve.
Siyabonga.
Siyabonga. Thank
Thank you. Gracias.
Muchos, what do you say in Portuguese? Muchos gracias. I wonder, Siyabonga.
Siyabonga.
Better than Okuyepa.
Siyabonga sasonga.
Thank you very much. What did you say, Siyabonga? What?
Siyabonga.
The next part. Things are not coming out. I think I should get a file and file some of your teeth, so that the sound can pass through. Right now, the teeth are blocking something. This is I've got a nice file there. Small numbers, so it will not be rough edges. You understand?
Yeah.
Okay, so when you look at this question here, they are giving you dy dx. Good. Which means they already,
Derived.
the function is already defined. We don't have the function. We have the derivative of the function.
So you can integrate it.
We don't have the function. We are not at integration yet, we will find the function. In fact, there is quite a lot of more things that you will need whenever you integrate. Okay? Especially to find out whether that function cut the y-axis. But so this is already derived. So in order for us to find the coordinates of the x coordinates of the stationary. What do we do here? We equate that to 0 because of the key word here,
Stationary point.
So you're going to say minus x squared plus 5x minus 4 is equal to 0. And then you're going to go up and divide or multiply by negative 1 on both sides because we don't like this, right?
X squared.
So it's just going to change the sign. So this becomes x squared minus 5x and then
minus plus 4.
plus 4 and then
0.
right. So this should
Straightforward.
factorize.
2
right?
negatives, 2 negatives.
That's a positive, so we look for 2 negative numbers. Negative 1, negative
No, negative
4.
Negative 4. Yeah.
What are you?
Yeah, I said negative 4.
You were there, you were hinting, you were okay. So what is 1 really? X is equal to?
Positive 1.
Or x is equal to?
Positive 4.
Obviously, taking this bracket, we let it equal to 0. Everybody understands that.
We get
This is ordinary level 1.
X sub
X minus 1 equals to 0. X minus 4 equals to 0. Therefore, x equals to 1. Second one, x equals to 4. Clear?
straightforward.
Then there's the next part to the question. They say, obtain an expression. I think this is the second derivative, am I right?
Exactly.
D squared.
Hence.
Yeah. Bam.
Abandon.
What else is the question saying?
And hence.
And hence.
Otherwise. Otherwise. Note.
Find what?
Nature of each of the stationary.
Find the nature of each of the stationary points.
points. With a note here.
Does it say each or
Each.
does it say each?
Each.
Of each. Of the.
Of each of the.
That's about it.
It's a lot of
But
each.
you get the idea. Of each of the.
Doesn't make sense. Who wrote this?
It's in the textbook. What do you mean who wrote? It's just that since it's there. You're also given a hint, by the way, in that same question. The equation is already differentiated as we already determined, and you don't need the y coordinate.
Yeah. So, see, how will you even find the y? We are not doing
Because when you are determining the nature of the roots, the x coordinate plays a role.
Because we have to substitute in
I hope you get that.
Second
point.
derivative.
Why don't we need the y coordinate?
because we're just going to use the x coordinates to substitute in the second derivative.
And that x value, that output here, already describes to us that. Okay? Because the equation is already differentiated. As opposed to the ones that we did previously, we had a function, and then they asked you to find the coordinates. Why did they do that?
Because it's sketching.
Why would they ask you to find the coordinates of the turning points?
For local maximum.
Why did I just say find the x coordinates?
For local maximum, local minimum.
Because you need the y value to
find
know
the local maximum.
what?
The local maximum, local minimum, to sketch.
For sketching, perhaps.
Yes.
Right? For sketching. Because those questions involve some sketching. And what else? There were questions there that didn't have to involve some sketching. Like, for example, the one we did. Question 1. Find the coordinates of the stationary points. The coordinates of the stationary points.
You said the coordinates.
Where's to find the coordinates of the stationary points?
Code.
Because they say the coordinates there, you have to find the y value.
Yes,
Substitute
the
them back
coordinate.
in there. But here, they
It's
say
looking
find
for
the x
coordinate.
Since it's already differentiated, there's no need there. You understand what I'm saying?
Is it?
Right?
English.
I think we also have, but you get that.
Yeah.
Okay, so
Just differentiate this. Derive
so we're going to derive the function. But this is the derived function
of this.
up here. Which is, okay, that's the equation. So we're going to take that. Please don't go and take this. This was just a method to solve the quadratic. There's something missing, but it's quadratic
Yeah.
equation.
Quadratic.
That's a method here.
The former.
Because we don't like the negative in front of the x squared. In fact, we don't like the value there. Okay, when we use factorization. So that's what we did there. So don't go and take this and differentiate that. Again,
Please.
we know what dy dx is.
Negative 2x.
So when we're differentiating for the second time, finding the second derivative,
Negative 2x.
then the square y dx square is equal to
Negative 2x.
negative 2x
Plus
plus 5.
straightforward.
The derivative of a constant is equal to 0.
Plus 0.
Now we are going to substitute what in there?
The X
The x values.
X sub
To
1.
determine the nature of the points.
X sub 1.
That's negative 2 by 1 plus 5. If you don't know this answer is 3, you have a problem, right? You still need a calculator. It's like 5 minus 2, okay? So that's 3. So what is going to be the nature of the point?
Local minimum.
Of the turning point. That's positive, so that would be a minimum.
Minimum.
Okay?
Local,
So,
local.
when x is equal to that, that's a minimum point. Don't assume, okay, that is going to be maximum. Let's always substitute there. All right, so if you don't know this answer is negative 3, you have a problem. That's negative 8. 5 minus 8 is negative 3. 5 minus 8 is negative 3.
34.
2
8.
times 4 is 8.
Eight.
Negative 8
Eight.
here.
Eight.
5
Take 5
minus
away.
8, negative 3. Therefore, this is a what?
Maximum. Maximum.
Ah, at least you're not sleeping.
It's a mix.
But you should be clear. Look at the example how they are writing the final answers because we're writing on the lines and stuff like that. Answer the question towards the end. You will go, let's say, therefore, not like what I did, you will say, therefore x equals to 1 is a maximum point, or minimum point in this case. And therefore x equals to 4 is a
Maximum point.
maximum point. Don't go right maximum. You are made from good stuff. We are cooking you very well here. Take a picture. And then you're not taking pictures. We are going to the next level. What is it? What is it?
You can take from there.
But you are taking pictures here with your phone, so
You can also take from there the videos.
the thing is, you put the video of
Calls are coming.
nothing, surely. I'm just asking. It's just a question. Don't catch any horrible things. How's Spanish doing? How's everything?
Anderson.
Stand or some? Yeah, man, what are you trying to achieve? They are using here today. Huh? You guys are watching South African series day, Generations, and what is this thing called? The Queen. This guy looks like he can watch the Queen. Yeah. Stop the tape! Stop the tape!